are going to look at the avian musculoskeletal system, and our focus is basically the bones and the muscle. So luckily, the some of the bones kind of have similarities to what we have seen in domestic mammals, like in the dog. So we are not going to go into so much details at this level, discussing different structures within the bones. Our focus here will basically be those bony structures that have to a large extent variation when we try to compare with that of mammals. And the key area of variation here, usually areas where you have fusion occurring within bones. So in birds, birds need to fly. So what they need to fly, in addition to their feathers, is light weight. So in order for them to have a lighter weight, we have reduction in bone size and fusion in between bones occurring. Instead of you having multiple bones, they fuse to become one. And also we have a pneumatization, that is air-filled spaces, air-filled spaces within the bone. So these are some of the structures that we will be focusing on primarily. And also the muscles. When we talk about the muscles here, of course there are several muscles, as we have seen in the mammals, but our primary focus here will be muscles of flight. So I wouldn't mind channeling all my energy talking about muscles of flight alone. So there are around 25 different bone types here. So the fuse. So majority of birds possess about 25 different bone types in birds, and these bones generally have been divided into two groups. So we have the pneumatic bones and the medullary bones. So when we say pneumatic bones, so these are bones that have hollow spaces. They have hollow spaces. That is, they lack bone marrow. They lack bone marrow. They lack bone marrow. So these hollow spaces are lined with mucous membrane. Mucous membrane. So what did Aka tell you about this space?
About the space?
Yeah.
There's air in there.
So where is the air coming from?
Oh, from their the respiratory system.
Yeah. From the respiratory system. Yeah. So the bone, the skeletal system communicates with the respiratory system. That is what this means. Yeah. So please, if you have forgotten how that works, please go back and review. So they communicate with the respiratory system. The medullary bone, this is opposite of what we have in the pneumatic bones. So we have no hollow space filled with bone marrow. Of course, they are also lined by mucous membrane, and we have some of these bones here. We have this humerus, some to a larger extent I've seen some literature say that they have a medullary space and this, but to a large extent they are a rheumatic bone. We have clavicular air sacs sending in air into these bones. So we have lumbar. In addition to this, we have lumbar vertebrae, we have sacral vertebrae, we have carpal, metacarpals, and as well tarsus and tarsus. So the skull of the bird, we are going to look at this from three different angles, that is three different parts. The first is we are going to look at this separate structure, which we are going to call the brain case. The brain case. The orbit is of interest to us. It is incomplete. The orbit is incomplete. And also the beak is of interest as well. In mammals or in dogs, for example, at what point do we have sutures after birth? Sutures?
No.
Really?
Yes. No.
there-
It's 50-50.
Yes.
There is.
Do we have sutures after birth?
Yes.
My anatomy professor would say that if you go out there and somebody asks you any question and you are able to answer, please don't mention my name.
So no.
Yes, we do.
But we said
Wait,
yes. And
why
then
you
you
said
said
that you're crazy?
What?
We all said yes.
and then you didn't answer, so then we said no.
You said no.
No, we said yes.
We said
It
yes.
looks like, yeah.
You're
Right here.
confusing.
So what did I ask?
If they have sutures. We
Yeah.
said yes. And then you didn't say anything.
After birth?
After birth.
Yeah.
I mean, I would hope so.
That was the question I asked.
Yeah, and you said yes.
So at what point? Okay, for
Until they
example,
mature?
is it possible to see a suture on the skull of a dog at 1 year of age?
Yes.
Yes.
Yeah.
Okay. So that was what I was asking.
And we
I
said
think
yes.
it's because we were
What did you
hesitant
say
to
no?
ask.
No, we said yes, and then you looked at us like we were
And then-
fucking crazy.
Yeah.
Like we had two heads.
Okay. Yes, we have sutures.
You're
Throughout all
So-
stages of life.
You're impossible.
So in birds, this suture disappears immediately after birth. So we are just primarily going to focus on key areas of variations, and one of the areas of variation here is the articulation between the mandibles and the skull, and we have seen how the condylar process, coronal process articulates with the mandibular fossa of the skull, and here the quadrate bone replaces this function, so it articulates lower jaw to the skull. This is a structure, a bony structure that articulates the lower jaw to the skull. So it enables the movements of the upper jaw as well. So it enables the movement of the upper jaw. In domestic animals, does the lower jaw is allowed to move, but here we have the upper jaw having the ability to move as well. So another structure we want to look at here is ossicles, sclera ossicles, or ring bone, as some call it, ring bone. So this bony structure is present in the bird, and this is what we have here. That is it there. It's present in fish. It's also present in fish. Okay.
I was like, tell me that's a bird.
Yeah, it could be a bird. Yeah.
New fear unlocked. I'm really good.
So the function of this bone is it's eye muscle attachment. It's the muscle of the eye attaches here, provides attachment for muscle of the eye. So muscle of the eye in dogs or domestic mammals, how do they attach to the eyeball? How do they communicate, or what's the association between the muscles of the eye, extrinsic muscles of the eye with the eyeball?
Touch the outside of the eye.
So what the point I'm trying to make here is that in dog or domestic mammals, we have seen that the extrinsic muscles of the eye are attached on the eyeball itself.
That's what I said.
Yeah. So here we have a bony structure referred to as the sclera. So instead of these muscles attaching directly to the eyeball, we have the sclera bone, where this muscle attaches to directly. And in addition to these attachments, this also provides protection as it prevents external pressure on the eyeball, so it supports protection, and we will say that it accommodates the cornea of the eye. So this structure is absent in mammals. So the occipital condyle, we have seen that we have two or paired in mammals, but in the bird, here we have one occipital condyle. So this is paired, this is unpaired. So this means that we will have a large range of movement here. So this will permit for a large range of movement, of which joint? Atlanto-occipital.
Is that why owls can turn their head?
Yeah, exactly. So we have the premaxilla, So this is found just under or inside the beak. So this is what we also refer to as the incisive bone, if you still remember, incisive bone. So the shape of these two structures, the upper and the lower jaw, varies depending on feeding habits of different birds. So this beak, we have seen some literature refer to them as bill. So we have different types of shape. Some are sharp, some are blunt, some are pointed, some are hooked. They kind of have a hooked tip. Hooked tip. So one unique feature of the premaxilla or the upper jaw is a very large nasal opening. So this is because of the requirement for air. Do you think that birds have a better respiratory system than humans or mammals?
Better?
Hmm?
What's your definition of better?
More efficient.
Efficient.
Yeah.
That's what we've been told.
And if it's wrong, then it wasn't Aka.
He's right, so it's Aka. So we have similar structures as we have seen in the mammal. So we are not going to go into these details. So if you know the topography of frontal bone, parietal bone, and all this in mammal, you should be able to, you know, estimate where these structures are found in birds. So they have a characteristic large orbit where the eyeball sits. So these are what we call ornamental structures. I'm not going to bother you much about these structures. So you can read about ornamental structures, and you have smooth, cone, wattle, etc. And so let's so have we seen anything close to this in mammal? Yeah. So in mammal, the choana is the passage from the nasal cavity into the nasopharynx, isn't it? From nasal cavity into the nasopharynx. So nasopharynx is absent in birds. So this opens into the oral cavity. It opens into the oral cavity. So the reason why nasopharynx is absent in birds is because nasopharynx is also to a larger extent formed by the soft palate. So as such, this soft palate is also absent. The soft palate is absent, as such nasopharynx is also absent. So these choanae or choana empties into the oral cavity. So at this point, we'll say that the food and air share a common passage. That is the oral cavity, and here the oral cavity. Air coming, so say food, and here we can say air. So this is structure that we have just looked at here. I thought you were asking a question.
Oh, sorry.
So what happens during when food comes in here? This closes to prevent the food from leaving the oral cavity into the nasal cavity to the exterior. So in mammals, we have also seen that there is auditory tube. We have talked about auditory tube that communicates with the middle ear, which we also highlighted when we were talking about the guttural pouch in our house. So this auditory tube is absent in birds, and it is being replaced by what we call the infundibular cleft, and these communicates with the middle ear. So
Middle or inner? Middle?
yeah.
Middle. Oh, trying to wake you up.
Are you having patella reflex?
You know what? It's a tired twitch, I think. You know, like when you're falling asleep and you.
Yeah, I get it all the time.
It's not you, it's me.
So we have seen. So what we have seen for the skull so far is sufficient. So the cervical vertebrae, nothalium, the hip bones, these structure what we want to talk about. We have areas, the vertebral column, where we have fusion occurring. So those areas of fusion, that is where we want to focus on primarily, and if there are other unique structures as well. So the number of bones within the cervical vertebrae in mammals is how many?
7.
So what about birds?
14.
Yeah, so the minimum you could get in what is it called in birds is 8, because they have a huge variation across different species and breeds of birds. And in chicken we have 14, and sometimes 17. So the birds like swan, they have as much as 25, which is the highest.
That's a Jeopardy question.
What was that?
So that's like a Jeopardy question, like a little fun fact.
No.
One day when I win $1 million, cause someone asks me which bird has the most cervical vertebrae and I say swan, I'll let you know.
Okay, good. So the ribs are flat and broad in birds, and they have a unique structure referred to as the uncinate process. So uncinate process, I would say, have three functions. We have attachments for muscles. So you can see that these structures here attaches or articulate with succeeding ribs. So these reinforce the rib cage, thereby providing strength. Provide strength to the rib cage. Strength. So respiration, especially inspiration, it aids in respiration, especially the inspiratory phase. So during flight, especially during downward stroke, the wings strike on the rib cage. So these uncinate processes give strength and stability to the rib cage within during this process. So the thoracic vertebrae in birds or chicken, we have seven. Usually, we have fusion difference. So sometimes you have variation in this fusion, but generally we will say that the first three, that is 1, 2, 3, are fused. On average, we'll say the first three are fused. So this fused structure is what we refer to as motarium. This fused structure is what we refer to as motarium. So this also has similar function to the uncinate process. It supports the chest during flapping, absorbing shock during landing. It is important to note that the ribs are fused distally with the sternum. In mammals, the hip bone is fused ventrally or dorsally. quality.
The hippo.
Are they fused dorsally or ventrally?
Oh, okay.
Yeah. They are fused ventrally, that is the pubic symphysis. That is the point of fusion. The reverse is the case in birds. So they are fused dorsally. So they don't give birth to their young ones alive. So all they need to do is to poop out eggs and so they don't need any support ventrally. Yeah.
I'm quoting you on that one when someone asked me. My anatomy professor said they just poop them out.
Would that be the
Yeah,
same for
but-
all
but,
egg-laying? Would that be the same for all egg-laying
Yeah.
species?
So the pelvic bone fused dorsally, and we have what we call sacrum here. Sacrum is a fusion of thoracic vertebrae, lumbar vertebrae, sacral vertebrae. So this fusion, anywhere we mention fusion, when we say what is the significance or what is the relevance of this fusion, the first thing that will come to the mind is to reduce weight, of the bird. So the tailbone fuse to form a structure called pygostyle, and this pygostyle gives support to tail feathers. Tail feathers. What?
Have you heard this? Is it ludicrous?
It might be. I don't
The
even
song?
remember. Shake your tail.
Yeah.
I don't know. It's just like shake your tail.
I'm gonna,
Shake
se-
your
I'm,
tail, brother.
I'm gonna send you. I'm gonna send you a song later.
You what?
I'm gonna send you a song later.
Oh, okay.
It's relevant.
Guy.
Okay.
Yes, shake your tail.
So talking about fusion, whenever there is fusion, whenever there is bone fusion, does it mean that the number of bones are reduced?
No, because then why would it, it has to be difficult for an exam.
I think they are reduced because if you have,
They're still there. They're just.
yeah, the fusion is goes a long way in reducing so many features.
But the number of.
Yeah, so you can't have the same structure, everything intact as you have for individual bone. So this means reduce number of bones, reduce bone numbers. So reduce bone numbers. Does it mean that you also have reduced muscle attachment?
If you're following the same
Yeah.
logic, yes.
Yeah. So reduce bones, then reduce muscle. Reduce muscle.
Reduce muscle or just
Muscle attachment.
attachment?
So muscle will be absent.
Oh, okay.
Yeah.
You are so impossible. I honestly feel like every time I think I know what you're gonna say, it's completely the opposite of how I would have. Yeah, very unpredictable with you.
So on muscle, like, well, there's no space for me to attach, so I don't necessarily need to appear here. Yeah. So, and this means in turn reduce weight. So, and if you look at pneumatization on the other side, also This also contributes to a reduction in weight. So if you are being asked to highlight those structures or features that contribute to reduction in bed weight, so all these comes in. So let's look at the chest, where we have the sternum, sternum, sternum. This is also referred to as the breastbone or the keel. The sternum, are they separate bones in mammals, or they are fused?
Separate.
Yeah, separate. So only in birds you see them fused. So it's fused to form a single structure present only in birds. So in mammals, if you can still remember, we have deep pectoral muscle, superficial pectoral muscle, subclavian muscle, etc. So these fusion affects the musculature. So here we are going to have the pectoralis muscle, two of them, which we are going to look at. These are muscles of flight that contribute to downward and upward stroke. Did we see this structure in mammals?
Yes.
Yes.
Okay.
Yeah, it was a process of something.
Yeah.
Yeah, so it is well developed here in birds. In fact, it is sometimes referred to as the strongest bone of the shoulder girdle. So the distal end of it is said to have a flat articular surface, and these fit or articulate with the sternum. So this is the during downward stroke, it limits the movements of the limb falling towards the keel, because here we have the heart, we have the lungs, we have vital structures. So this tries to also limit these shoulder movement towards the keel from the pull of the pectoralis muscle. So I'll quickly mention this here, since we already have it here. We are going to look at this again when we come to talk about the models proper. So this is to this, and this is to this. This is to this, and this is to this. Downward stroke. Up stroke.
So the humerus goes to the pectoralis muscle on the downward stroke, and the humerus goes to the supracoracoideus on the upward stroke.
You said what?
Yeah.
He said the supracoracoideus goes up for upward, and the pectoralis is for downward.
Are you pointing that the humerus is moving up and down?
Forget about it.
Okay, excellent.
Sorry.
We'll come to that. So the scapula is narrow, thin, flat, curved. And articulates with the humerus cranially. So this scapula helps to stabilize the shoulder during flight. So the uncinate process stabilize the rib cage. The scapula, we have muscles attaching these to the rib cage as well that helps to stabilize the rib cage, and this also helps to stabilize the shoulder during flight. So we have the coracoid here, humerus here, and this is a clavicle. So this is also referred to as the collarbone. Collarbone. So it is a thin and rod-like structure. It articulates with the coracoid proximally. So this is fused to form what we call furcula. So the fused collarbone is what we call furcula. So what is another name for furcula? Yeah, wishbone. Why is it called wishbone?
Because you make a wish on it.
Hmm?
You make a wish on it.
When you snap it.
Yeah, you snap it in half. On Thanksgiving, which is in a few days, and we'll be here in your class celebrating. So. Oh, we'll be dissecting chickens.
Oh, so
So we can do the wishbones.
yeah,
Oh, cute.
it sounds like. Yeah, except for those that don't want to euthanize.
I'll do it, I just don't want to do it. I can't do it.
You catch them, we'll euthanize
Yeah,
them.
you go catch the thing, and then we'll euthanize it.
Okay.
We'll get a video of you running around chasing chickens.
So what happens to this bone here during upward and downward stroke? One is supposed to move. One of the stroke will cause this bone to move laterally. One of the stroke will cause the bone to move medially. So which one?
Down is medially. Right? Well, if
So it's
you're,
gonna open?
well, if you're going down, you'd be closing your.
There are two strokes. So downward stroke is going to move laterally. Then
Dive.
upward stroke is going to move medially. So this helps to maintain certain distance between the shoulder and also the. So does this have any clinical significance apart from the wishbone, apart from the making wish? Hmm?
Helps during flight.
Clinical significance, it breaks easily?
Hmm?
You said clinical significance, does it break easily?
The heart is located just beneath the wishbone. So, inserting your needle, so this is the landmark. This is the wishbone, here is the landmark. So during the dissection, we want to see how we are going to place our needle here to be able to target the heart. The pectoral limbs, this also referred to as the forelimb or the wings. So we have number 4 here, pneumatic foramen, which communicates with the clavicular S-ax. In mammals, the ulna and the radius, which one is larger? In mammals,
Radius.
why?
Jeez.
Why?
Radius.
You guys are making me sad. The radius.
Oh.
It's fatter.
Okay.
The radius is larger. You can see those.
Your little friend is missing here.
Who?
That big ass cow that's always here. I
Yeah.
know, but he's normally here so I can see him.
Yeah, it's usually here
Your
during
friend.
first semester. During first week. So reverse is the case in birds. So the ulna is larger than the radius, and it is more medial, medially located, and it articulates with the humerus proximally, and here we have a characteristic large interosseous space. So how many rows of the carpal bones do we have in mammals?
Three.
Rows of carpal bones.
Rows of carpal bones.
Yeah, three.
2,
Yeah, we have
Oh,
two.
rows, something called.
3 in the back part. In the carpus. What's the other one? Tarsus.
We have two. So we have proximal row, we have distal row in mammals. Here, so this is where we have the carpus is between which bones?
The radius and the metacarpus. Radius, ulna, and metacarpus.
Okay. So here we have fusion of the distal row with the carpal bones, with the metacarpus. That is the metacarpus. This fuse with distal carpal bone. So it means we are going to have only one row left. So the fusion of this is what we now refer to as the carpal metacarpus. So only the proximal row is unfused. And here we are going to be left with two bones, that is the ulnar and the radial carpal bone. The ulnar and the radial carpal bone. So here we have 3 digits. digits 2, digits 3, digits 4, digits 2 referred to as the alula, and digit 3 has multiple phalanges, that is 2 phalanges. How many phalanges do we have in dogs?
3.
3. So here it's either 1 or 2. So talking about alula, we are going to talk about how that helps during flight. We have what we call a reciprocal apparatus here. These, is it time?